So, thank you Professor Sholapurkar and Bhaskaracharya Pratishthana for the opportunity to deliver this series of lectures on Brahmagupta. So, my first part would be a general introduction. Now, I would like to remind you of what was Swami Vivekananda on the day of his passing away, on the day of his Mahasamadhi, had said. If there were another Vivekananda, then he would have understood what this Vivekananda has done. This is very much relevant for this series, that to understand Brahmagupta, one needs another mathematician. So, in general, it requires another perceptive great to fathom the greatness of a truly great in any field. So, Bhaskaracharya was such a perceptive great who had fathomed the towering greatness of Brahmagupta. So, it is quite an emotional moment for me that this series is happening in an institute named after Bhaskaracharya, because it was Bhaskaracharya who referred to Brahmagupta as Ganaka Chakra-Chudamani, crest-jewel among mathematicians. Now, my question is, has modern India known and understood the immensity, depth, impact and the magical quality of Brahmagupta's work? So, there is almost the attitude taken to ancient mathematicians like Brahmagupta is as if they are like mythological characters. They are very much historical personalities, but they are not mentioned in our history books. So, let me first connect Brahmagupta with the standard history, that is with the standard textbook history and geography. He was born in 598 Common Era, and all this information is coming from Brahmagupta's text itself. And his father's name was Jishnugupta. So, 598, let us relate to the history that is more or less known. So, this makes him a contemporary of Harshavardhana, the emperor of Kanauj, in the first half of the 7th century. And also, to understand Brahmagupta, one has to really breathe the atmosphere of the time. What was the era like? This is called in history as the classical age. So, we had a Vedic period and the post-Vedic, which is more historical. There was a golden age in the post-Vedic Indian history, which is called the classical age. It was a period of robust intellectual activity. There was a magnificent efflorescence in various fields, whether it's philosophy, literature, mathematics and science, art, architecture and polity, and Brahmagupta came out of in that golden period. So, just to give some idea about the chronology, about the big names which we learn in history. So, his predecessors include Samudragupta. Brahmagupta is born in 598, worked in the early 7th century. So, just a few centuries back, there was a Samudragupta. Just after that, the great poet Kalidas, and after that, Aryabhatta. So, Aryabhatta was a great predecessor of Brahmagupta in astronomy and mathematics. Now, next is that where does he hail from? So, we don't know where he was born, but we know from the text about his place of activity, that is Bhinmal. And this Bhinmal you can see in the modern atlas. It is a place in Rajasthan, close to North Gujarat, in the Jalod district of Rajasthan. And this was earlier called Bhillamal. It was also called Shrimalinagar. And this was once a very famous city It has been described as a very beautiful city. It was prosperous. It was a great center of learning, trade, and pilgrimage. Hiuen Tsang, in his account on India, he mentions about Bhinmal. So it is here that Brahmagupta composed his famous work, Brahma-Sphuta-Siddhanta. During the reign of, again he mentions the king, Vyagramukha, who is described as an ornament of his race, the Chapa race. And there is another Sanskrit poet who hails from Bhinmal. He is Magha, the author of Shishupal Vada. So this is the birthplace of Magha. Then there are important Jaina texts written in Bhinmal during 7th to 10th centuries. And this was also a great center of temples, which, as you know, got destroyed. But there is in late 20th century or early 21st century, a fantastic Jaina temple has been constructed on the outskirts of Bhinmal. That's one of the places of interest. But anyway, I am not highlighting that because that is something modern. And Bhinmal was the early capital of what was called Gurjar Desa or Gurjaratra. And the modern name Gujarat comes from this. But it was not exactly modern Gujarat. It was a region comprising southern Rajasthan and northern Gujarat. And it is mentioned in the biography of Harsha by Banabhatta. And of course, it is mentioned by Hiuen Tsang. So one representative of Bhinmal, just to give you an idea of place, is this poet Mahakavi Magha. But you may be wondering that why I am showing the postage stamp of Magha. The talk is on Brahmagupta. I just wanted to make a point. There is no postage stamp of Brahmagupta that I know. So as you know, Brahmagupta gave the D0 in algebra. 0 has a value. So Brahmagupta's stamp, there is nothing to be filled. So this is a reflection of our 20th century India. And I have a question here. That is there a deep-rooted conviction among us that this ancient India, I mean, that is entitled to be mentioned only in the context of subjects like literature, philosophy, maybe art and architecture, and not in fields like mathematics and science. In mathematics and science, ancient India is treated something like a mythology. Is that the reason why we have a stamp on Magha of Bhinmal, but a more impactful person, Brahmagupta, there is no stamp. And the only place I know where Brahmagupta name occurs is in a hostel in TIFR, which is named after Brahmagupta. And I can share an anecdote. In our institute, there was once a name was being sought, and it was mentioned by the director the name should not be Mahalanobis or very standard name like or Jawaharlal Nehru, something which is new for a special fellowship that was to be introduced for students. And I had given the suggestion of naming it after Brahmagupta because that is something which is not mentioned. This happened some 20 years back. As a result, the fellowship is not being named after anybody. However, just for your amusement, an artist has drawn the pictures of several mathematicians in the form of postage stamp from a fictitious country called Mathematica, and Brahmagupta features there. And this this was a very last moment addition, this slide. I was reminded of this because just yesterday or day before yesterday, I got a video of, he is very much in the news, William Dalrymple. He has been highlighting about Indian contributions, though not always accurately, but he has been highlighting. So in this video, he says that very few people outside India know about Aryabhata or Brahmagupta. And my reaction was that this adding the phrase outside India, was it needed? In fact, outside India in Germany, there is a sketch of Brahmagupta which you don't find inside India. Again, to get a picture, because you see this, all of a sudden when somebody mentions about Madhavacharya invented calculus, there is a kind of a shock. So when you mention something about Brahmagupta, there is a disbelief, because one reason is that one doesn't have a feel for the time. So since this is an introductory talk, I just would like to revise the history of the era of Brahmagupta. Now, so this is Sri Aurobindo in his series of articles which are published under the general title, The Foundations of Indian Culture. So he has given the characteristic features of the Vedic age and the post-Vedic age. So here the post-Vedic is what is relevant. The second or post-Vedic age of Indian civilization was distinguished by the rise of the great philosophies, by a copious, vivid, many-thoughted, many-sided epic literature, by the beginning of art and science. Beginning of art and science. And you can see this Aryabhata and Brahmagupta being pioneers in various things. It's a part of a pattern. Beginning of art and science, by the evolution of vigorous and complex society, etc., etc., formation of large kingdoms and empires, by manifold formative activities of all kinds, and great systems of living and thinking. Here, as elsewhere, in Greece, Rome, Persia, China, this was the age of a high outburst of the intelligence. With ancient India, we have an association of the spirituality, which is of course very much, that was the primary motive. But we forget that there was also a high outburst of intelligence, and because we forget, claims about Brahmagupta shock people. So this was the age of a high outburst of the intelligence. And so another quote which I would like to highlight it was a birth time and youth of the seeking intellect. Birth time and youth. These two phrases you should keep in mind when you think of the Brahmagupta's contribution to algebra. Both the birth, you will see the birth of algebra and the youth of algebra in his work. Each department of knowledge or activity once taken up was pursued to its extreme with an amazing intensity, a powerful, penetrating and scrupulous intelligence. In the words of Sri Aurobindo, so Sri Aurobindo mentions about the features of ancient India. The first was the spirituality, second was an extraordinary vitality. So I am not quoting that. What is relevant for me today is that the third feature, the third power of the ancient Indian spirit was a strong intellectuality, at once austere and rich, robust and minute, powerful and delicate, massive in principle and curious in detail. So all these are contrasting phrases. So you see, just let us look at one of them, something like robust and minute, how it is relevant in mathematics. You see, there is that people who are mathematically very rigorous, that means very meticulous, give attention to minute details, they are sometimes very slow in this progress. I mean, there is some kind of lacking in robustness. Whereas people in more applied areas, they are more robust. They, they learn a lot at a faster rate, but they ignore, matters of minute details. The characteristic of the ancient India was that it was both robust and minute. Both, the intellect was powerful as well as delicate. And so massive in principle, working, about things like astronomy, and curious in detail, working on the basics of mathematics. All this together you find in Brahmagupta. In each subject, from the largest and most momentous to the smallest and most trivial, there was expended the same all-embracing, opulent, minute and thorough intellectuality. So why I am quoting this? Just to say that Brahmagupta is a striking embodiment of this vibrant intellectuality. This is what I would like to illustrate during this course, and why it is important to keep this background. You see, I'll mention a big name in history of mathematics as well as in mathematics, that is van der Waerden. Van der Waerden questioned Brahmagupta's contribution to what is called Pell's equation. He believed that it could not have been done by Brahmagupta, and therefore it must have been done by Greeks earlier, from which he got it. And what was van der Waerden's argument? That Brahmagupta was an astronomer. Why would he be interested in, a topic in mathematics like Pell's equation? So this is the havoc that ignorance can cause, and the arrogance of ignorance. So therefore, one has to see the entire panorama of Brahmagupta's work, nothing in isolation, and also the entire panorama of the era of the time. Now we come to Brahmagupta proper. So Brahmagupta's texts, the known texts are, there is a small book, Dhyana Graha, but that's not talked about much. In fact, I don't know much about it. But his real magnum opus is Brahma-Sphuta-Siddhanta, which was written in 628, that means when he was 30 years of age. It has 24 chapters of 1000 verses in both astronomy and mathematics. And there are two major chapters in mathematics. Actually, there are some more, but they have not been processed because the manuscript is in such a defective condition that he has chapters on combinatorics also, but that's not available in proper edited form. So among the available chapters in mathematics, the major chapters are arithmetic, which includes geometry, and algebra. And you can see the thing that arithmetic, geometry, etc., that is the mathematics which is more popular mathematics, that is about 66 verses, and in algebra it is 102 verses. And then there is another text which is basically on astronomy. And I forgot to add that in 1817, Colebrook had published the English translation of chapter 12 and chapter 18, and that is probably the first time that this modern modern scholarship, that means in the scholarship in the English language, came to know about precise details about Brahmagupta's work. So that is 1817, that's a landmark year. Now what I will do is that today in this introductory thing, lest we get lost in details, at first let me just summarize some of his landmark contributions, and then in this series we will take up some of them in detail. So first, alongside his prolific, so Brahmagupta, as you can see, the chapter on mathematics, there are 2 or maybe 4 chapters on mathematics among 24. So he is known mainly as an astronomer, and that creates the confusion. But alongside his prolific contributions to mathematical astronomy and other applications, what Brahmagupta had done was to firmly plant a culture for the pursuit of fundamental research in mathematics. What is roughly called pure mathematics, but you know that there is now controversy about the word pure, but I think there cannot be any confusion regarding the word fundamental research. So this is something in which Brahmagupta is a pioneer, and it is after Brahmagupta you can see a series of works devoted to mathematics, like you have Sridharacharya's works in mathematics, Mahaviracharya, exclusively to mathematics, then Sripati, Bhaskaracharya, of course, Narayan Pandit. So they have separate works on astronomy, but focused text on mathematics, it starts with Brahmagupta's 2 chapters. And what I will take up in the next talk is the creation of the subject algebra as a distinct discipline. Now, the importance of algebra in modern time cannot be overstated, and it is he who created the subject. So, his mathematical foresight can be seen in his recognition of the discipline and his early realization of and emphasis on the importance of the subject. And what we will do in the next 2 lectures or maybe next 3 lectures is to elaborate on David Mumford's statement. David Mumford was he is still there, he is a Fields medalist, the highest recognition that a mathematician can get. It seems clear to me that Brahmagupta is the key person in the creation of algebra as we know it. This is a loaded phrase, as we know it, because there will be controversies. You see that so and so had done algebra before Brahmagupta, but then the confusion is regarding what is meant by algebra. So, Mumford says that the algebra as we know it, the creator is Brahmagupta. So, what one should note is the Brahmagupta's development of symbols in algebra, notation, terminology and formation of equations. In other words, the language of algebra that was developed by Brahmagupta. Then Brahmagupta's rules of arithmetic operations involving negative numbers and 0 and his treatment of surds. His solutions of quadratic equations, again this is the first time that the solution of the quadratic equation would be stated for arbitrary coefficients. Simultaneous linear equations by the method of Gaussian elimination. Linear indeterminate equation, that means you have a linear equation like ay minus bx equal to c, which where a, b, c are integers and you find integer solution to such equations. So, that was pioneered by Aryabhata and Brahmagupta developed it further. And the most astonishing part of Brahmagupta's work is his anticipation of what we call as modern abstract algebra. The quintessence of modern abstract algebra you see in Brahmagupta through his composition laws, which were called Bhavna in ancient India. And now there is a magazine named Bhavna as a tribute to Brahmagupta's composition law, which he used to give partial solutions to quadratic indeterminate equations. Now, arithmetic, basic arithmetic is not due to Brahmagupta, that is of course much older, but Brahmagupta's, what is remarkable is Brahmagupta's systematization of arithmetic, especially his expositions on fractions and his applications of algebra to arithmetic.
The idea of indeterminate there?
Yes, solution of integer solutions of equations.
Indeterminate, x, ksha.
Yes, yes, yes. Now, one interesting aspect of Brahmagupta's work is the introducing the statistical concept of weighted arithmetic mean, and that comes up in his treatment of excavation problems. That is, let us say that when you to estimate the volume of a ditch or the depth of a ditch where the depth is uneven, then to get a representative depth, he uses this, he introduces the concept of weighted arithmetic mean. Then Brahmagupta's second order interpolation formula, which is, there is a typo here, it is Newton-Stirling's formula up to second order, and other results in trigonometry, and the seeds of calculus got sown through his methods. So, so don't get me wrong, I am not saying that Brahmagupta did calculus, but again why it is important to know about Brahmagupta's work, because you see nowadays one hears that Madhavacharya had results in calculus and analysis, and there is again there is a shock to accept that. But if you see that what Aryabhata and Brahmagupta had done, then you will realize that what Madhavacharya did, or the Madhava's school did, was a natural culmination of a process started by Aryabhata and Brahmagupta, which includes this second order interpolation formula. Then his results in geometry. So, regarding geometry, let us make it clear that Indians had done spectacular works in Vedic time. Then later, you know that Greeks had done phenomenal work in geometry, and the heights reached by the Greeks were not attained by any other civilization, including India. The Indian strength was in arithmetic. India in the post-Vedic. Vedic India was strong in geometry, but post-Vedic India was basically arithmetic and algebra. However, there is some exceptions here, that Brahmagupta's results on cyclic quadrilateral, they stand out as solitary gems in post-Greek and pre-modern geometry. And so he gives the area of a cyclic quadrilateral and each diagonal of a cyclic quadrilateral, and he also gives interesting constructions of triangles and cyclic quadrilaterals, all of whose sides, area, diagonals, all of which are rational numbers. So, he blends his number theoretic and geometric skill to do that. So, we shall elaborate on some of these 7th century landmarks. So, just keep this in mind, that just as Kalidas is the great representative poet of the classical age, Brahmagupta is its great representative mathematician, as Bhaskaracharya had recognized and called him Ganaka Chakra-Chudamani. So, I think I'll end my first talk here. Any questions?